Good morning class. Today we discuss D and F block elements. Student, group 3 to group 12 elements of periodic table are considered to be D block elements because their valence electron enter in D subshell. I repeat again, group 3 to group 12 elements of periodic table are considered to be D block elements because their valence electron enter in D subshell. They have general electronic configuration n-1 d1 to 10 and s0 to 2. Students, the learning technique of D block element that belong to group 3 to group 12 elements are: it is a star TV cable में फी कू नी कू जी, that is the scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. The learning technique is star TV cable में फी कू नी कू जी. Thereafter यूं जरा ना बनो मानो तुम्हारे रूप रंग पर अजी कह दिया. Yttrium, zirconium, niobium, molybdenum, टेक्नीशियम, रुथियम, रोडियम, पैलेडियम, सिल्वर, कैडमियम. आई रिपीट इट अगेन, यूं जरा ना बनो मानो तुम्हारे रूप रंग पर अजी कह दिया. इट्रियम, जिरकोनियम, नायोबियम, मोलिब्डेनम, टेक्नीशियम, रुथियम, रोडियम, पैलेडियम, सिल्वर, कैडमियम. नाउ Cd के साथ Hg, Ag के साथ Aus, Pd के साथ Pt, देन ईश्वर, ओशो, रजनीश, विंटर तक हाफ लेके. Here La is a lanthanum series followed by 14 elements. They are hafnium, tantalum, tungsten, rhenium, osmium, iridium, platinum, gold, and then mercury. Here actinium. So these are the D block element which have the general electronic configuration n-1 d1 to 10 ns0 to 2. Now it should be noted the element zinc, cadmium and mercury are not regarded as a transition element. Here one thing must be noted, zinc, cadmium and mercury not regarded as transition element because their d subshells are completely filled, therefore they not show the property of transition elements. Now let us discuss their properties one by one. Number first one is the metallic character. As we know that D block elements lies between S and P block elements, so they are also said to be transition elements. Now let us discuss their metallic character. All the transition elements are typical metals with strong metallic bonding between them. Therefore, they are hard, having high density and high enthalpy of atomization. While we dealing with the property of D block element, we are dealing with first property, that is metallic character. All the transition elements are metal with high melting and boiling, high melting point. They are hard, possess high density and high enthalpy of atomization due to strong metallic bonding in them. It should be noted the highest density of D block element is, the element which have highest density among the D block element is iridium. Iridium has a maximum density approx 22.6 gram per cubic centimeter, while the scandium element is there which has the least density. It is 3 gram per cubic centimeter. I repeat it again. All the D block elements are metal with high melting point due to strong metallic bonding in them. They have high density, high enthalpy of atomization due to strong metallic bonding in them. Here one thing must be noted, iridium has maximum density approx 22.6 gram per cubic centimeter, while the scandium has the least density approx 3 gram per cubic centimeter. Now let us discuss the second properties of D block element, their melting points and boiling point. As we discussed earlier, D block elements are metal with strong metallic bonding in them, therefore they have high melting and boiling points. They have high melting and boiling points. It should be noted mercury exists in liquid state due to weak metallic bonding in them. Also it has completely filled the subshell. Here one thing must be noted, mercury exist in liquid state because their d subshell is completely filled. Also, it has weak metallic bonding in them. Now let us now here the elements manganese, Mn and technetium show anomalous high melting points. It is due to exactly half filled d subshell. I repeat it again. Manganese and technetium show anomalous high melting point due to half filled electronic configuration. Now let us deal with ionization enthalpy. As we move from left to right, their ionization enthalpy decreases till the middle, and then first decreases till the middle and then increases gradually. I repeat it again. Ionization enthalpy increases as we move from left to right. Here one thing must be noted. 5D transition element possess higher ionization enthalpy than 3D and 4D transition elements due to greater effective nuclear charge because of ineffective shielding of the nucleus by 4f electrons. Now let us deal with atomic and ionic radii. It should be noted atomic and ionic radii of d block elements are smaller than s block element but greater than p block element because d block lie between s and p block elements. Here one thing must be noted, as the atomic number of element in particular series increases, the atomic and ionic radii first decreases till the middle, then become constant and then increases towards the end of the period. One of the most important property of d block element is oxidation state. Here one thing must be noted, transition elements show variable oxidation state. Transition elements show variable oxidation state due to the participation of Ns and N-1d electrons in bonding. I repeat again, transition elements show variable oxidation state due to the participation of Ns and N-1d electrons in bonding. Lower oxidation state is shown when Ns electron participate in bonding, while the highest oxidation state is shown when both Ns and N-1d electron participate in bonding. Here one thing must be noted, manganese, that is Mn, Z is equals to 25, exhibit oxidation state from +2 to +7. I repeat it again, manganese, Z atomic number 25, exhibit oxidation state from +2 to +7 because it has exactly half-filled electronic configuration. One thing must be noted, scandium, Z is equals to 21, doesn't show variable oxidation state. Now let us discuss one of the most important property of transition element, that is complex formation. It should be noted, transition element form complex due to smaller size and the high charge density of the ions. Presence of vacant d orbital of appropriate energy can accept a lone pair of electron donated by the group. In short, we can say transition elements have tendency to form complexes due to their smaller size, high charge density and availability of vacant d orbitals. Now let us discuss colored complexes. Transition elements and their compounds are colored due to absorption of light from visible region, which result promotion of electron from one d orbital to another, that is dd transition take place. I repeat it again, transition elements and their compounds are colored due to absorption of light from their visible region, which results promotion of electron from one d orbital to another, that is dd transition take place. Here one thing must be noted, Zn double positive salts are white in color due to completely filled d subshell. Also technetii 4 positive salts are colorless due to empty d subshell. Now let us discuss the magnetic properties. Transition elements are paramagnetic and their paramagnetism can be explained in terms of magnetic moment. I repeat it again. Transition elements are paramagnetic due to presence of unpaired electron and their paramagnetism can be explained in terms of magnetic moment. That is mu is equals to under the root n plus 2. Here n is the number of unpaired electron and its unit is B dot M dot, that is Bohr magneton. Here n is the number of unpaired electrons. I repeat it again. Transition elements are paramagnetic in nature due to the presence of unpaired electron and their paramagnetism can be expressed in terms of magnetic moment, that is mu, represented by mu is equals to under the root n plus 2. Its unit is B dot M dot, that is Bohr magneton. Here the formula to calculate magnetic moment, it is mu is equals to under the root n plus 2. Now let us discuss catalytic property. Transition elements are good catalysts because they show variable oxidation state and have large surface area. It is one of the most important questions frequently asked in CBSE examination. Why transition element act as good catalyst? Transition element act as a good catalyst because they show variable oxidation state and also have large surface area. That is why most of the electrolysis process, transition element like platinum, gold, silver, rhodes, etc. are used. Now alloy formation. Because of similar radii and other characteristic of transition metals, alloys are readily formed by these metals. Interstitial compound. Transition elements have an ability to entrapping smaller atom of carbon, hydrogen, nitrogen in their interstitial site to form interstitial compound. I repeat again. Transition element have an ability of entrapping, means holding smaller atom of carbon, hydrogen and nitrogen to form interstitial compound. Interstitial compound generally have high melting point, less chemical inertness than pure metals. Now the question arises, why is highest oxidation state of metal exhibited in its fluoride and oxide only? Student, highest oxidation state of metal exhibited in its oxide and fluoride only because oxygen and fluorine both are most electronegative element. They can oxidize metal to its highest oxidation state. Now let us discuss a question which is based on magnetic moment. We have to calculate magnetic moment for M double positive Z is equals to 27. First we have to write the electronic configuration of an element M having atomic number 27. It is 1s2, 2s2, 2p6, 3s2, 3p6, 3d7, 4s2. Since 2 positive charge is there, now we are losing 2 electrons. We get 1s2, 2s2, 2p6, 3s2, 3p6, 3d7, 4s0. Since 2 positive charge is there, 2 electrons are losing. Now D sub shall have 7 electrons. We know that D sub shall have total number of orbitals are 5. 1, 2, 3, 4, 5. It's a 3D, 7 electrons are there. Now filled according to the Hund rule. 1, 2, 3, 4, 5, 6 and then 7. Here we notice that number of unpaired electrons are 3. Number of unpaired electrons are 3. And we have a formula mu is equals to under the root n plus 2. We have a formula mu is equals to under the root n plus 2. Now putting the value of n in the given formula, we get mu is equals to 3 plus 2. That is the value of mu comes out to be 15. That is approx 3.85 B dot M dot, that is Bohr magneton. So by this way we can calculate magnetic moment for M double positive Z is equals to 27 and more species. Now one more question frequently asked in CBSE examination. Why Cu single positive ion unstable in aqueous solution? Here Students, Cu single positive ion unstable in aqueous solution because it undergo disproportionation reaction as follows. Here Cu single positive goes to Cu having oxidation number 0, that is reduction take place. In the second step, Cu single positive goes to Cu double positive, that is oxidation take place. When oxidation and reduction take place of single element, when both oxidation and reduction of single element take place, the process is called disproportionation reaction. Since Cu single positive undergo disproportionation reaction, therefore Cu single positive is unstable in aqueous solution. Student, today we discuss D block element. As we described earlier, group 3 to group 12 elements of periodic table are considered to be D block elements. They are also said to be transition elements. We are dealing with their properties, that is metallic character, melting boiling point, ionization enthalpy, atomic ionic radii, oxidation state, complex formation, color formation, magnetic properties, catalytic property, alloy formation, and the interstitial compounds, and some questions we discuss. Thank you very much.